Hello, my name is Christoph Wichmann. In this video I would like to explain how you can, or I would like to demonstrate how you can deploy the Axway API management solution on the Google Kubernetes engine. For that I'm using the Helm chart from this cloud automation repository, and I have already configured my Kubernetes cluster that is running, and I have also my my kubectl communicating, running with that Kubernetes cluster, and of course I have also Helm installed. I'm going to use the API management or API namespace. The Helm chart itself is agnostic to the Kubernetes distribution, and you're using your configuration values, your local values, to adjust the deployment objects to your distribution. And for that, we are providing a few examples, and this is the example for Google Kubernetes engine. And a few things have to be done before we can get started. And the first thing is that we are creating some Ingress resources. Of course, at the end, you would like to have the API manager, portal, traffic, and so on running. And for that, it's a good idea to have a domain registered. And of course, you can register that domain anywhere you want. But I have decided just to use the Google Cloud environment. And for that, I went to networking services and then cloud domains. And here I have my domain name Axway API-Management on Google Kubernetes engine.com registered. So, and the DNS-Entries in this demonstration, maybe it is possible, maybe not, I don't know, will not be dynamically updated based on the Ingress resources. I will go and maintain them manually. So that means I will register then a host name, Admin-Node-Manager, manager, portal, and so on, and link it to the IP address of the generated load balancer. So certificates are for the load balancers. So that means the load balancers, of course, do need a certificate, and this takes a while. Let me quickly say I would like to generate managed certificates. So you have the choice to use managed certificates, or you can use your own certificates. I am using these managed certificates, so that means for the Admin-Node-Manager, a certificate is generated, for the API manager, for the API gateway, and so on and so forth. That's the idea. And these certificates are then linked as managed certificate to the service using an annotation. So, by the way, that takes really, really long, and it can take long. You have to wait until this status before so that the certificate is finally active, and otherwise you cannot make any requests to the load balancer. So the Ingress controller, I'm using in this demonstration the standard Kubernetes Google Kubernetes Ingress controller, which has a limited set of functionality. But as the purpose of this demo is not, let's say, to talk about Nginx configuration or any other custom Ingress controller, I stick with that. And the Google Kubernetes Ingress controller is limited also, let's say, supporting annotations for Ingress resources to configure health checks. It is necessary in that case to register some backend configurations, and these backend configurations do contain a health check configuration. So let me create that. So now we have for the Admin-Node-Manager, for the API manager, and for the traffic some specific backend configuration. There is no backend configuration needed for the API portal, and these backend configurations are then linked to the services in the provided values YAML file, like so. So this is, let's say, already prepared. So with that, we can prepare the installation using Helm. And for that, I'm using the provided example which is over here, which configures a number of things. I will explain a few of them as part of that video after we have triggered the installation. So let me get a local copy of that file. So now I have it over here. And now, as really everything takes a moment to have provisioned it, let me run the Helm command, the Helm install. I name the release Axway API-M in the namespace with my local values file. And this is the Helm chart we are going to use. So it is deployed, or it's going to deploy it, of course. And now we can see what happens. I'm going to the Kubernetes engine, to services. And here we can see now that we have a service for API Manager, Admin-Node-Manager portal. Of course, you can enable and disable certain components using your values file. In the values I just used, as you can see, everything is basically enabled, let's say the core API management components. Let me check here locally for the pods, how they are created. So that means it starts with the Admin-Node-Manager. The Admin-Node-Manager is currently waiting for the metrics database. Once the metrics is running, Admin-Node-Manager will start. Then I believe traffic starts and API Manager starts and so on. So that means there are, of course, dependencies between the different services. So API portal is waiting for the API Manager now, and the Admin-Node-Manager is coming up. So also Ingress resources are created that are ultimately creating load balancers in the networking section of Google. So let's see if we already see some load balancers here. I sometimes have to reload the entire page to see the load balancers. Obviously not yet created, so let's wait a moment and check again here ingresses, because we need to find the generated IP addresses, and I believe also here I can see the IP address once the load balancer is created, but not yet. So that means we have to wait until the load balancers are created. So here is an error message. So that means the cloud platform, Google Cloud Platform, is trying to create a load balancer and is saying that load balancer blah 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 does not exist, invalid ingress, front-end configuration, please check the usage of your annotation. So I believe that disappears automatically after a while. So that means it just runs in the background. So I recommend that we are just waiting for the ingress to be created. In the meantime, a few words about the configuration file I have used. And this is, of course, the domain. This is the domain I had registered before. You saw this. This is my Docker repository from where the API Gateway and API Manager and Admin-Node-Manager images are pulled, with that image tag by default, which can be overwritten by these different components. So the Admin-Node-Manager is configured like so, and basically all of the other services are configured quite similar. It should be enabled. Would like to have this as an Ingress resource. And here, depending on your Ingress controller, of course, you would have to use other annotations. For the Google default Ingress controller, I'm saying it should create a load balancer finally with that managed certificate, Admin-Node-Manager managed certificate. I don't want to have HTTP enabled on the load balancer, and this is basically optional as it is the default anyway. But just for reference, this is where you would have then to configure your own Ingress class like Nginx. Some things for Ingress and for the load balancer and backends, Healthchecks and so on, are taken from the service itself. And that's why I have to set some annotations on the service and say that the backend protocol for the Admin-Node-Manager, and this is the named port of the service, should be HTTPS. Only with that, the health check to the backend works and the service becomes healthy. And this is the backend configuration we have created before, and this is basically the reference to that. I believe this is not necessary anymore, as it is stored in that local values file or in that backend config we have created anyway. And this is also not absolutely necessary to have the EMT trace level. In general, all these values you can override. So that means here it is stated that with your local values, you override everything that is in the base values file. So that means I can check here for the Admin-Node-Manager maybe, and then you can see service, type, cluster IP, Ingress, enabled, annotations, and so on. That's the concept of that Helm chart, and as of many other Helm charts, so that you override the whatever you need in order to make it running with your environment. So let's see if we now have an IP address. We do. So let me go to the load balancers. And again, try to reload the entire page. And now we see the load balancers, because now I have to, because the certificate, which the managed certificate is currently bound to that HTTPS socket, and this is at the moment provisioning, and it needs to become active, and that takes a while. And one thing they do is, of course, to make sure that this host name is finally reachable, and for that I have to update my DNS server, which I will do manually. So that means I take the IP address from here, and I'm using Google Domains, where I say for this domain, I'm going to update the IP address. So this is for the manager, I believe. Yeah, API Manager. Then we have the Admin-Node-Manager. The Admin-Node-Manager. We have the portal. This is the portal. And what else? And the traffic, of course. So this is the traffic. So Kibana is just not necessary at the moment, and that's all. If you do not do this, then the certificates cannot be generated, because Google is validating that the host name is visible and that it works and so on. So now that really can take time, not only 10-15 minutes, it can take much longer. And so let's wait until these certificates are populated. So what else to tell? As you can see, API Manager is quite similar configured. There are, let's say, the name of the named port is a different one. Also the backend configuration, also for the API portal, and so on and so forth. So that means quite straightforward. So one more thing maybe that is interesting is about the persistent volume claims. In my case, I have disabled all persistent volume claims, and with that it is using an empty dir for the events, for the open traffic, and for the traces. So that means here you can enable that, and then you have the possibility checking the base values to set up, let's say, a persistent volume claim that is compatible with your environment. So that means here you can say which claim you would like to create in order to get the volume provisioned. So that depends also on your environment, which storage classes you have available. There is a problem sometimes here that at Google especially, to have the possibility to mount the volume with read-write many. But I don't want to, let's say, focus on that at the moment for this demo. So let's see. Then backends, Healthchecks for the load balancers. Let me quickly go to Kubernetes and to the services. and let's say for the API manager. So, and that looks all good, all good. So now I believe it's all up and running. I was about to check for the health check and to explain to you how this is linked. It's sometimes hard to find everything. So target load balancer, backend services. Just for information, this is based on my understanding. This is just the, let's say, general backend service, like the host. And this is the service itself, in my case, the API traffic itself. And let me check where the health check is linked. Yeah, here's the health check for the backend service. And this is the health check we have created. So that means if I go into that health check, I can see now call that /health check, use HTTP, use port 8080. And this is exactly the health check as it is defined in the file for the backend configuration which we have applied. So I mean this file here. So now we have to wait until the certificate becomes active and has been signed successfully. And as I said, this can take time, and that's why I'm going to pause this video now. Let me finally check for one of these certificates. It's already visible, which is good, which is active, but this is not yet sufficient. We are waiting for the certificate chain to be completed. So welcome back. In my case, it took about 20 minutes to have the certificate finally ready and active. And also, if the certificate becomes active, it takes a while, obviously, that the load balancer is realizing this and really working with it. And it might be still the case if I now use the browser to hit the Admin-Node-Manager or the manager, that you get a certificate error, even if the certificate is already active. Another important note, that I had to disable my VPN for any reason, but I don't want to dig into that and figure that out. So that means, let me check if I can call the API manager. The API manager is running. Let me check for the Admin-Node-Manager. Admin-Node-Manager, HTTPS. The Admin-Node-Manager is not yet running. So this is the error you may see when the certificate is not yet ready. So that means it might be the case at the moment that it just takes another, I don't know, few seconds to get this load balancer updated. So let me try this again. It doesn't work, but let's wait. Then let's check for the portal. The portal is already okay. And also let's check for the traffic. Of course, there is no API, and make sure yeah, it's all good. So then let's wait for the Admin-Node-Manager, and you cannot really see, let's say, in the load balancer status. Of course, there is a possibility somehow to see that in the logging services, but from the node manager itself, from that load balancer, it all looks good, and there's nothing you can do. You just have to wait a little bit longer, a few seconds. So let's see if this one comes up. Maybe I made a configuration mistake, but I don't think so. Let's try another browser. Sometimes that helps. No, that's, by the way, the error message you get from Firefox. And this is clearly the error you see when the certificate is not yet ready. So let's check for the certificate. Maybe the certificate is not yet ready and only the other one was ready. So that means that even takes a little bit longer until this certificate is ready. So that means now it is. And try it again. As I said, it might take a moment, even if the certificate is ready, to have the load balancer updated. So very likely they are running now in the background a process to bind this certificate to the load balancer, and I'm pretty sure that takes around, I don't know, 30 seconds, a minute or something like this. So let's wait. Just give it another URL just in case. And make sure again to have the corporate VPN disabled. In the meantime, we can try to log on to the API manager. Change the password. Okay. Oh, that's interesting. Whatever this was. But in general, I would say it is running. Okay, let me try this one here to avoid any caching or something like this. But still the load balancer. But it is a good example, as you can see, that takes a moment to have this load balancer here updated. Let me also check again the IP address. Oh, that is okay. So, too bad. Why does it take so long? I'm pausing this video again to avoid that you have to wait until this becomes ready. So now, after a few minutes more, also the Admin-Node-Manager is working. And let me check for the status. And so that means we have the API manager running. We have our 2 API gateways registered to the topology. And to finally see that also the traffic is working, we go and say that we would like to call this. Let me just copy and paste the URL and say it should be traffic, and we call that hello world. So now it's returning a 4.4, which is okay. And here we have the hello world API call. So that's basically everything I wanted to show in terms of how to deploy the API management solution on Google Kubernetes Engine. And yeah, I hope it was helpful. Thank you.